And our next data type is called date time. So before I hit the enter key, what information would you guess is stored in an object of the type date time? I'll give you a few seconds to think. Okay, time's up. If you guessed a date and a time, then you are absolutely correct. And you'll see that you're correct when I hit enter. And with that revelation, we end the rocket science portion of this segment. But stay with me, because in this segment, not only will you learn how to use date time, but you'll also learn the answer to the burning question, which segment in this course wins the coveted MBS award? Most boring segment. Spoiler alert, it's a tie between date time and new string. Note how I'm violating the rule of effective teaching that says that I should convince you that whatever I'm teaching is fascinating? Okay, but that rule sometimes conflicts with the other rule of good teaching. You know, the rule that says I should be honest with my students. I'm going with the second rule. Now let's get started because, sorry, I'm already getting sleepy. So we've started here with the function that has the same name as the type, date time. When you call it without an argument, the way we just did, it reads your computer's calendar and clock and returns the date and time as an object whose type is date time, as this blue label says. The time has three parts, hours, minutes, and seconds, separated by colons. These colons bear no relation to the colon operator. They're just simple punctuation. And MATLAB displays not only the value of the date-time object, but the name of the type in an underlined blue font, exactly as we've seen it do for structs and cells. And as for those types, the data type name is a live link. It'll pop up a window with documentation on the type when we click it. But instead of reading about it, I'm going to tell you about it. So I'm going to close this. So now you know the exact date that I'm making this segment, and the time right down to the second that I gave this command. Or do you? Maybe not, because if you change the date or the time on your computer, then this function's output will change right along with it. What you don't know is that I just set my calendar and clock to a fake date and a fake time just to fool you. So as a matter of fact, you don't know when I'm doing this segment, and you don't know when I gave that command. And by the way, I could fool you right down to the microsecond if I wanted, because you can change the default display mode for the date time objects to go out to a millionth of a second. And you can make the month come out before the day and even change the language in which the name of the month is given. Just click Preferences up here in the Home tab, click the command window, well, it's already clicked, and then change the defaults in the date time format. If, for example, you want to imagine that you are in Paris, or better yet, some charming village in Provence, like, say, Châteauneuf-du-Pape or Peugeot, you just type FR, lowercase, underscore FR, uppercase, for Français en France. And instead of July, you'll see Juillet. Oh, and I almost forgot. If you want to see microseconds, you just add a decimal followed by 6 S's right at the end here. And after you hit OK and type date time again, you'll get the date in French and the time out to 6 decimal places. And you can even take it out to 9 decimal places because times are maintained in nanosecond precision. Okay, let's set the format back to the default. and we'll go from there. So you can also call date time with an argument like this. And I think it's intuitive what you should get. Yesterday gives you yesterday's date, today, today's date, tomorrow, tomorrow's date. And all three of these time points are determined by the computer's clock. By the way, MATLAB's name for any one of these arguments is relative day. And it provides one more relative day that I'll show you in a minute. That's all, though. You can't ask for the day before yesterday or my wife's birthday, which would really be good for me. They left both of these out of the option list, but that's not a problem, right? This is MATLAB. It's dead easy for you to write your own functions for both of these. While you're at it, it'd probably be a good idea to include mother-in-law's birthday. And speaking of leaving things out, I'm calling this time point, but where is the time in these outputs? We got a time before. Well, when you ask for yesterday, today, or tomorrow, the MathWorks programmers figured that you're not being specific enough to include a time, so it leaves them out. On the other hand, if you use this fourth and final so-called relative day, they consider that now means not only today, but this very hour, this very minute, and this very second. And they give all that to you. Of course, that's exactly what we got up here when we called the function with no arguments. So how would you use this function? Well, you use it when you need to write your own function that includes automatic documentation of the date and or the time. Let's look at a function that does that. I've written a function called openWebPage over here that lets you open a web page. I'm going to make some room to show it to you. There. But you know what? Let's run it first, and then we'll look inside it. As you can see, the function's prompting me to enter the URL that I want to visit. I'm going to type in cs103.net. This particular web page is one that Akos and I maintain for this course, and you can use it to get directly to our videos by clicking right here on Video Lectures, and then scrolling down here and picking a lecture that you want to see. I don't know. We're using a function. Let's do introductions to functions. Nice little cheery introduction. Oh my gosh, who's this guy?
So far what we've learned is how to perform individual operations with MATLAB, and we've used MATLAB as a glorified calculator.
Yeah, we've learned a lot.
Now it's time to start programming.
Well, we hadn't learned how to iron our shirt, have we?
Remember that we've called a few of MATLAB's built-in functions. For example,
how come his arms keep stretching out?
To calculate the sine and to do other things.
There they go again.
There's hundreds more functions that we could call.
Yeah, hundreds of functions.
That's not provided by MATLAB.
Guess what? Oh, yeah.
And we can use them just as if they were built in MATLAB.
Enough of this guy.
Let's see how.
Let's close this browser. Oh, look at this. Look what the function printed here in the command window. It says that at such and such a day, such and such a time, you open the web page at such and such a URL, and it gives us a cheery little "Have a great Saturday." This is an example of what I was talking about when I said your function can include automatic documentation complete with date and time. And then to end on a very friendly note, it wishes us a great Saturday. So now you know that I'm so devoted to your education that I'm working on this video for you over the weekend. Or am I? Maybe today is actually, I don't know, Monday, and I've changed my computer's date to a Saturday. Well, whatever day it is, and I'm not telling, it's time we looked inside this function to see how it works. First of all, it uses the input function right here to request the URL from the user. You might notice that the input arguments, enter the URL, and S, are both of the char type instead of the string type. That's because as of version 2018A, the string type does not yet work with this function. If you have a later version, it might work for you. But here in August 2018, we're not there yet. This second argument, this S in quotes, tells input that the user is going to type in characters with no single quotes or double quotes. It'll then automatically put whatever characters the user types, up to but not including enter, into a char vector, which will be returned by the input function and assigned to the variable named URL here. Next, it checks to see if URL is empty, which means that the user didn't type anything, and it'll quit. This return function does that. But if it doesn't return, then it uses datetime to get the date and the time and stores it into the variable search time. Next, it calls the function web with the string inside URL, which is a char vector because that's what input returns. However, unlike the antiquated input function, you can give a string to web and it'll work just fine. We then check the status returned by web to see how well things went. This status does not tell us whether the web page was found, it just tells us whether the web browser could be run. 0 is good news. It means that the web browser did run. And with that good news, we print out this message that says you open the web page and at the search time. Of course, that's hidden behind the web page so you don't see it until you close it. Or, of course, move the web page window. If status is anything other than 0, that's bad news. And we print out the bad news message here. Could not start web browser. And notice that we've used the modern string input instead of char input for this fprintf, and this fprintf, and this fprintf. And next it determines the day of the week. To do that, it uses a function called weekday on this line, which returns two output arguments. The first one is an integer from 1 to 7 that gives the number of the day of the week, with Sunday being number 1, which agrees with the standard in about half the world. But if your country uses Monday or Saturday as the first day, don't worry because this function doesn't use that argument anyway. That's why we have this tilde here. Tilde tells MATLAB to throw that argument away. The second output argument is the name of the day of the week in the form of a string. And that's what we want. We save it in the variable named weekday_name here, and we'll use it in this printf function. But what about the input arguments? There are two of them. It gets its date from search time, and the second argument tells it to spell out the name of the day of the week instead of giving an abbreviation for it. That's long format, so we'll get SATURDAY instead of the abbreviation SAT. And then finally, here in this printf statement, which again uses the brandy new string format, the function prints a cheery little message telling us to have a great Saturday. So that's how this function uses the datetime data type. But there are many other ways to use it, and there are many more functions for manipulating this data type. Let's get a list of them. You remember how to do that from the previous segment? Type doc in the command window. Click MATLAB. Click Language Fundamentals. Click Data Types. Click Dates and Time. And click Expand All if you want to see a whole list. And there they are. Each of these links will take you to a help page for one function. And there are a lot of them. Again, I'm not going to go over all the functions in the list. I do have a few more things to show you, but once you've gotten an idea of what's involved with this data type, or any data type, And you know how to get a list of links to the help pages for all the functions that are especially designed to manipulate objects of the data type. You can do anything with it that I can, and you don't need me to do it for you. It's like the old saying goes, give me a fish and I eat for a day. Teach me to fish and I eat for a lifetime. And as we've clicked through these documentation pages, you've learned how to fish for useful data types. Well, we've already used date time. Let's see here. So I'm not going to click on that. And you can see something here interesting below it called NAT. That means not a time, or for that matter, not a date. It's like NaN, which you'll remember is a particular value of the double type that means not a number. Well, now MATLAB has added NAT as a special value of the date time type to mean not a time. You can use this value as an element of an array of date times to indicate that this element has not been entered or is not yet known or something like that. But I want to move on to these so-called duration functions here, which create objects whose type is called a duration. Each of these functions return an object that's a little different from a date time. A date time object represents a particular point in time, like 2:30 p.m. this afternoon. But a duration object represents a length of time, like 2.5 hours. Well, let's take a look at that. We'll get rid of this page first, and let's use the hours function. And here's how you get a duration of 2.5 days. There's something big going on here in MATLAB's display of these duration values. It's not the word duration, which gives the type in that good old underlined blue bold font, which we've seen before. No, the big thing is something entirely new. It's the inclusion of units. Units of hours indicated by the abbreviation HR, and days. When have you ever seen MATLAB use units? As we pointed out what seems like an eternity ago in Lesson 1, when we were talking about using MATLAB as a calculator, there's no way to specify units for ordinary numbers, doubles, singles, int8s, etc. So if you calculate the speed of light, MATLAB can't tell you whether the result has units of meters per second or miles per hour, or for that matter, pounds per square inch. It's just a raw number. But duration objects are different. We'll see other units show up in other duration examples below. So we know what a duration object is, and we know that they have units, but what can you do with them? Well, for one thing, you can add them to date time objects. You can subtract too, like this. In these three examples, we've used addition with the years function to get a date 3 years in the future, and used addition and subtraction with the days function to get dates 3 days in the future and 3 days in the past. In each day, the time remained the same, but you can add or subtract hours, minutes, seconds, or milliseconds to change the time. I'll let you try that yourself. I'm going to clear the command window and get more space, but before I do that, while the years and days functions are still on the screen, it's a good time to point out that the names of the two functions, years and days, and also their sister functions, hours, minutes, seconds, and milliseconds, are plural. They've got an S on the end. You'll need to remember that because there are also functions with singular versions of these names, like day, year, and second, that have very different meanings. We'll get into them in a few minutes. For now, though, I'm just warning you that it's easy to trip over the plural versus singular difference. I've done it many times. Okay, let's clean up and get more room. Adding and subtracting is not the only way to get dates in the distant past or future. The datetime function also takes arguments that can get you any point in time you want directly, like this. Big event in Berlin on that day. It was a big event for the whole world when that fiasco was finally torn down. But at least it made it obvious how bad an idea a border wall is, and it made it unlikely that that mistake will ever be made again. It should also be obvious that the three arguments that I gave date time are year, month, and day. And you can get any point in time you want. Here I've given 6 arguments, and you probably noticed from that little pop-up that the last 3 are hour, minute, and second. The armistice to end the fighting in the First World War was famously signed in 1918 at the 11th hour of the 11th day of the 11th month. But whose 11th hour? I say that because if you look around the world, it might be 11 o'clock at one place, but 5 o'clock in another place. Well, it was signed in London, and we can set this date time to be specific to London's time zone. To set the time zone, we first have to find out what London's time zone is. Time zones are managed worldwide by the Internet Assigned Numbers Authority, which is best known for assigning Internet numbers. That should keep them busy, but they handle time zones in their spare time. You can look all that up. But MATLAB saves you the trouble by providing a handy function called time zones. Which opens a web page in the same way that our little open web page function did. Now to find what we're looking for, we click on the little search icon over here. Looks like binoculars. And then we type London into the search box. And there's what we're looking for, the name Europe/London. We can now close this site and set the time zone property of our datetime variable to the string Europe/London. We do that by using the dot operator. This is the same dot operator that we use to set fields and structs, like this. Nothing changes because there was no time zone set for this variable before. But let's make a copy of this variable. Copying a variable copies everything in it, so its time zone property is copied too, as we can see if we query it. But now if I adjust this new variable's time zone property to correspond to, say, Nashville, which is in a different time zone from London, we'll see a change. Despite the worldwide fame that this MOOC has brought to this city of Nashville, it hasn't been quite enough to earn us a coveted spot in the IANA list. But we happen to be in the central time zone with Chicago, which has made it into the list, and I happen to know its time zone name. So, we see that it was 5 a.m. in Nashville and Chicago when the armistice was signed. The minute and the second aren't important, and as far as I know, they're not even known. So why did I include 0 minutes and 0 seconds up here when I specified armistice WW1 was in 1918, 11/11/11? Well, if you're going to give an hour, you have to give a minute and a second too. This is what happens if you don't. So I've given the year, the month, the day, and the hour. And we get this message. Error using date time, line 581. Numeric input data must be a matrix with 3 or 6 columns, or else 3, 6, or 7 separate numeric arrays. And then it tells us another way to do it. Well, we put in separate numeric arrays, which happen to be singletons. But we put in 4 of them. which makes sense if you don't know the minute and the second. MATLAB could easily have accepted this input and filled in the zeros for the missing values. But no, they couldn't do that. They'd rather send us this big, long, harsh message. Okay, Mike, get a grip. Anyway, this dot operator, which we used here, here, and here, reveals that these datetime variables are implemented as structs. Since a datetime variable is implemented as a struct, you can use the function called field names to see all its fields. And because of the way we're using it, it looks like a struct, but it's definitely not a struct. It's still a datetime. It just uses the dot operator to access its properties and the field name function to see their names, one of which is time zone. These property names are fixed and they're case sensitive, and you can't add new fields the way you can for a struct. These 8 are all you get. Okay, the fighting stopped on the day the armistice was signed, but the official end of the war had to wait until the peace treaty was signed, which in turn had to wait until the leaders of the countries involved had completed their required 228 days of squabbling. My goodness, this has turned into a history lesson. What was I talking about? Oh yeah, MATLAB. We've added 228 days to November 11th, and that puts us at June 27th. But what happened with the time? Why did we end up at noon instead of 11 a.m.? Can you guess? Daylight savings time. It went into effect in Europe in the spring of 1916. The U.S. started it in 1918, then stopped it, then dithered about it, turning it off and on and letting it vary from state to state for 89 years until 2007, when it became uniform across the country. Fortunately for us, though, MATLAB takes care of adding the daylight savings time hour for us, so we don't have to deal with that irritating detail ourselves. That's a great advantage. Thank you, MATLAB. It's a great advantage indeed when the time of day is important, but in the case of the Treaty of Versailles, it's not, because nobody took any special notice of it. So we shouldn't show any time at all for the treaty signing. We just want the date. Well, you can get rid of the time by using another property in the list above. The format, like this. And you can use the format property to do a lot more than simply omitting the time. You can change how the date time value is displayed too. For example, maybe you like this short format. Day, month, year. Don't forget to use uppercase for MM because lowercase means minute. There are 40 plus formats that you can put together in millions of combinations, and you can find all of them in the date-time documentation page by scrolling down to Properties and looking for Format. And in that list, if you prefer a very long format, you'll find all this. The 4 E's give you the day of the week, and thanks to it, we now know that the Treaty of Versailles was signed on a Friday. Talk about TGIF. But that's enough history. Let's get back to those functions called day, year, minute, and so forth that I was warning you not to confuse with the plural versions that we used before, like years, which, if you don't remember it, works like this. There's a couple of interesting things here. First, there's a 100-year anniversary coming up next June. Second, the anniversary will be on the 27th, but for some reason we got June 26th. Why is our calculation off a day? Well, the reason has to do with leap years. The function years treats all years as having the same number of days, 365.2425. which is the length of a year averaged over 4 centuries. However, the actual number of days in a year is 365, except on leap years in which the leap day February 29th is inserted into the calendar. So while years agrees on the average with the calendar, it does not agree exactly for every year. Fortunately, MATLAB has that issue covered too. To get exact agreement, just use the function calYears, which means calendar years. It'll keep up with the entire leap year schedule for you. Now you can mark your calendar for the big celebration. How do you celebrate the end of a war? Maybe you buy fireworks and then don't set them off? Anyway, you can see from this how important calYears is. And there are other calendar functions too, such as calmonths, calweeks, and caldays, and calquarters. But maybe you could just look those up in the date time documentation, because we need to get moving. Oh my gosh, do you realize how many side tracks we've gone down while these singular functions have been waiting to get on stage? Don't you just love a good mixed metaphor? I mean, we had to get through time zones, daylight savings times, formats, and leap years, for goodness sakes. But we're ready for them now. To make sense of them, it might help to know that these functions, which are named year, month, week, day, hour, minute, second, and quarter, are very old functions that had already been around at least 8 years when the date, time, and duration types were added in 2014. Those old functions were originally part of the library for handling problems in finance, which, like engineering, is a big application for MATLAB. And those old timers were immediately updated to accept the new data types as input arguments. But at the same time, the language designers saw a need for some new functions that also dealt with years, days, hours, minutes, and seconds. These new functions had to have different names, so they made them plural. Okay, so finally, let's see what these functions do. And there's minute and there's second too. In the date time documentation page, you'll find these functions under the heading Split Dates and Times because, as these examples show, they split off parts of the date time. You can even determine which one of the 4 quarters of the year the date occurred in. You got to be able to do that because those financial folks are preoccupied with quarters for some reason. These split functions are pretty simple, really, but if you forget how they work and try to get information from the help function, there's a little problem you should know about. Let's say we ask for the year function. At least this is what I get, and it should be similar to what you get if, like me, you have an installation of MATLAB without the financial toolbox. It's not very helpful because it doesn't explain what the function actually does. And what does tall array mean? Well, that's an advanced subject, but tall arrays can come in handy if you have an application that works with so-called big data, because it allows you to set up arrays with hundreds of millions or even billions of elements, despite the fact that they won't fit in your computer's memory. But in any case, this is where help takes you when there's no financial toolbox installed. On the other hand, if you've installed the financial toolbox, or if you're using MATLAB Online, which always has all the toolboxes, you'll end up in a different room of the documentation with a help page that's even less helpful because it gives wrong information about what the function does. At least it's wrong if you want to know what it does with the datetime object, which is what we want to know. But no matter which of these 2 rooms you find yourself in, here's how to get into the datetime room. Just look for the message See Also and the blue link named datetime/year. Or if your installation doesn't show that link, look for a blue link named Other Functions Named Year. Click on that, and the link labeled datetime/year should appear. Either way, click on this link, go through the 2 doors in front of you to enter the Hyrule Castle, kill Ganondorf with a Master Sword. And wait, sorry, now I've gotten off track a little bit here. You're actually there. Your quest is over. You've won the game. And as victor, your final reward is to get to see what the function does and what its inputs and outputs are. So that's that. And let's get out of here. This place with all its secret passageways and everything is kind of spooky. So we finally learned how to use the functions year, day, hour, etc., which split out parts of a datetime object. And we've learned the secrets of capturing their help pages deep inside MATLAB's documentation cave of wonders. But guess what? There's another way to split out that information, and you've already seen it. Remember this? Well, you can get the year, day, and hour of the armistice with the fields year, day, and hour, like this. Just don't forget to capitalize those field names. And if that's not enough, you can look up the functions YMD, which means year, month, day, and HMS, which means hour, minute, second. In every case, the values you get back from these many splitting operations are doubles. None of them will give you a duration object. The only way we've seen to get one of those is to use a plural function like years and days. But there is another function that will give you a duration, and its name is pretty easy to remember. Duration. Let's see. Its input scheme works like datetime, except that it starts with hours instead of years. These inputs are 3 hours, 7 minutes, and 43 seconds. And the output is the same, but it's printed with colons to separate them instead of commas, like the datetime. Again, these colons are unrelated to the colon operator. You can even give a fourth argument, which contains milliseconds. I always want to know how long my movies are down to the millisecond. And what can you do with this duration? Well, for one thing, you can do arithmetic with it. Want to know what half of 3 hours, 7 minutes, and 43 seconds is in terms of hours, minutes, and seconds? Nothing could be easier. One hour, 33 minutes, and 51 seconds. You can multiply, subtract, and add, too. Whoa, that would be a long movie. And this last example is the most interesting one. It uses mixed mode arithmetic, meaning that we have 2 different types as input to the arithmetic plus. The 2 different types are duration and double. First off, the type of the result of the operation is duration, as we can see here, instead of double, and that's what we wanted, so that's good. But the more important thing about this example is that we've added 1 to the duration, and it went up by 24 hours, from 3 up here to 27 down here. That's revealing. It means that the basic time unit of duration is the day. It's also the basic unit of date time. That's a common thing. Microsoft uses day as its unit in Excel spreadsheets, for example. So that gives me a great idea. If the basic time unit is the day, then a duration must be stored as a number of days. So we should be able to see the number of days in a duration by converting the duration to a double, like this. Another great idea shot to heck. MATLAB just won't do it. It tells us instead that if we want to convert a duration to a number, we have to do it with the seconds, minutes, hours, days, or years function. So why do you think that is? Well, it's because there's no way for MATLAB to know what number I want. I wanted days, but I could just as well have wanted the number of minutes too, or seconds. Here's the number of seconds. And here's the number of days. Which is what I wanted. Got to know how many days my movies are. And while we're on the subject of arithmetic, yet another way to get a duration is by subtracting two date times. Let's do that to find out how long the 7 Years' War lasted. And I got to clear the screen again. I'm getting to be a real neatnik. There. So now I know that the 7 Years' War lasted 59,160 hours. Let's get that in years. So the 7 Years' War should be called the 6.7489 Years' War. You might want to make a note of that. You know, I probably shouldn't say this, but in my opinion, this is an example of just how sloppy these historians are. They'd sure never make it as engineers rounding things off to the nearest whole number. I'll tell you that. Let's find out just how far off they are in days. "91 days of war that never happened. Stopping early probably saved a lot of lives. Thank goodness the people that actually decided to end the war weren't historians." It's important to note that this subtraction has to account for the number of days in each month. 28 in February, 31 in March, and 30 in April. Hey, let's repeat this subtraction for the same dates in the following year, 1764. I'm going to copy this previous command from the history with the up arrow, and then change each 3 to a 4. There's an extra day. By now you probably know why. 1764 was a leap year, so its February had 29 days. So both of these subtractions gave us the number of elapsed days, and each number is in the neighborhood of 90. But there's something strange in the neighborhood. Where's the word days? Remember how I was talking about how durations have units, hours or weeks, for example, and how it's such a nice feature? And where's the word duration in bold, underlined blue letters? Well, days and duration are missing because the type of the variable returned by days was double in both cases, not duration, as we can show using class. And come to think of it, we saw the same thing happen when we calculated how many days our long movie lasted. But when we first used days, we got the whole 9 yards. Well, actually days, not yards, and it was 2.5, not 9. Remember this? So are we losing our minds here? 1 minute days returns a value of type duration, and the next minute it's returning a double. How can a function behave differently from one call to the next like that? Well, it's time for me to bring up polymorphism for the 100th time. This function and its siblings, years, minutes, etc., are polymorphic. The type of their output depends on the type of their input. Their outputs are durations when their inputs are numbers, and their outputs are numbers when their inputs are durations. Okay, that's the rule, but the next question is, why is that the rule? Why don't these functions return objects of the type duration no matter what type of input they get? Of course, there are certainly some cases in which we would want a double instead of a duration, so we could feed the answer to functions that require the double type. But in that case, couldn't we just convert the duration to a double using the double function? You know, like this. Oops, yeah, I guess I kind of forgot about that. We already explained that double couldn't convert a duration to a number because it doesn't know what units you want. So that's not going to happen. The solution that those clever girls and boys in Natick, Massachusetts came up with is to have the 6 functions, years, days, hours, minutes, seconds, and milliseconds, do the conversions from duration to double and from double to duration. They can do it because the name of each function reveals the units that the user wants. And they can do all 12 conversions with 6 functions instead of 12 functions named, you know, double to years, years to double, double to days, days to double, etc. Well, let's clear the screen again. And that's enough arithmetic on date times and durations. But there's a related thing you can do. You can compare points in time using relational operators. Let's do an example of that. First of all, let's specify a couple new points in time. Now let's generate some random days. I'll initialize the random number generator so you can duplicate my results. Like that. What I've done here is start at the beginning of the session, go back 30 days, and then with that starting point, I've added 5 days by calling this random int generator, asking it to produce a 5 by 1 column of random numbers selected from 1 to 100. And this is the result. We get a 5 by 1 array. Let's see which one of these comes during the session. Now obviously you can look and see which ones come during the session. But suppose there were 1,000 of them, then you'd need MATLAB's help. Now what I've done here is set during session to be equal to a logical expression. Here I've got a relational operator, less than or equal, and I'm comparing the start of the session with these 5 dates. The result will be a column vector, true or false. True if the start of the session comes on or before the date, or to put it in another way, true if the date is on or after the start of the session. And over here I'm checking to see whether the dates come on or before the end of the session. Then I combine this first vector of results with this second vector of results using an element by element AND operator. And we get a 5 by 1 logical array. True, true, false, true, true. We got 4 out of 5 hits. This is our first example of a vector of type date time. But you can do column vectors, row vectors, you can do 2-dimensional and higher also, just as with all the other types in MATLAB. And as you might guess, we can do these same things with duration objects too. Create arrays of them and use relational operators to compare them. For a more readable result, you can convert to string, as we've seen before. And it's just as easy to convert the date times themselves to strings. For example, and you can convert durations too. Conversion to string is important when you're building strings that incorporate date and/or time information. Here's a function that uses it to make a 1-month calendar. Let's get a little bit of room so we can see it there. Let's run it and then we'll talk about it. I've given it two inputs, 8 and 2018, and that means 8th month and the year 2018. And it gave us a calendar for August of 2018 in the form of a string column vector with 11 elements. This function is available in the reading assignment for the week of this lesson, as are all the functions listed over here in the current folder, so you can try them and study them yourself. I'll simply point out that this function converts a datetime object dt to a string on the third line after it constructed the datetime object on the first line and then formatted it on the second line. The format determines what comes out in the string. The actual numbers that go into the calendar are gotten from the calendar function, which you can read about in the datetime documentation. As we just mentioned, we use the dot operator on the datetime object dt in this function. And in the example before that, we use plus and minus operators with datetime and duration objects, and we've even used multiplication and division. As a guideline for using operators with these types of objects, a good rule of thumb is that if it makes sense, it'll work. And there's one last operation that I want to show you that makes sense, the colon operator. Don't worry, I'll make this short. Let's just dive into an example. In this colon operation, we put datetime objects at the beginning and at the end, and a duration object in the middle. To answer the burning question, how many fortnights were there in 2018 from March 27 to May 13th? And as you can see, there were 1, 2, 3. The last one started April 24th and ended May 8th. And there's another way to get a sequence of datetime objects. You can use a double for the increment, like this. I'm going to be lazy and just edit the previous command. There. And as you can see, this double is treated as a number of days. We get exactly the same result. And you can get a sequence of duration objects using the same idea. And here again, putting a double in gives you a number that's treated as days. Okay, finally, and that's finally as in finally all this date time stuff is about to be over, you can use date times and durations in plots. Look, I know you're sleepy and tired. Heck, I've drifted off 5 times myself while I've been talking to you. But we're almost done, and this plotting business is fun anyway, and easy. We'll be done in a jiffy because MATLAB has made plotting with date times and durations so simple. I've got some data in my workspace that's been waiting all this time to be plotted for you. So let's haul it out and take a look at it. It's a set of times and heights for the tides at Sanibel Island in Florida. That island's one of the great places in the world to find shells. And the shelling is best at low tide and worst at high tide. So it's important to shellers to know how the tides change over time. There are roughly 120 tides per month in Sanibel, and most places for that matter, alternating high and low. And I've got a month's worth of them right here. Let's look at the first 16. So we've got 16 date times and we got 16 heights. These are in feet. And so we see on the 1st of August at just 2 minutes after 4 a.m., the tide was at 2.25 feet, and then at 10:03 a.m. it had dropped to 1.25. So that's a high and a low. And there's a high, low, high, low, high, low, and so on it goes. There's about 4 a day, as you can see, on August 1st and August 2nd. On August 3rd, there's only 3, but the next one happens just past midnight. Well, you can look at all this data and try to make sense of it, but there's nothing like a plot. My goodness, this still looks pretty complicated. Like maybe there are 2 superimposed patterns, one with big swings and one with little swings. But at least the plotting is simple. The plot function works the same with date-time vectors as it does with any other vectors. You just give it 2 vectors like this with the same number of elements, in this case 120 each, and it plots one against the other. And we can examine the plot as usual. I'm going to stretch this one out horizontally. Click Tools, then Options, Horizontal Zoom, and then stretch the plot out horizontally with my mouse wheel. As I do that, you can see that these are not overlapping graphs of big swings and small swings at all, but there is actually a high tide, then a low tide, then a kind of little high tide, a little low tide, and then high tide, and it repeats and repeats. And let's see how far apart these are in time. Here's a low tide at about 6 p.m. and a high tide, the little one, at about midnight. Then another one, a little low tide at 6 a.m. and then at noon you get another high tide. So these things are swinging back and forth about 6 hours apart. This pattern is duplicated with, some variation at every coast in the world. And it's caused by the interplay of the moon, the earth, and the sun, and with some secondary effects caused by local land shapes. The guy who figured all this out for the first time was Isaac Newton. But you'll need to find a course on physics and astronomy to really understand that. Fortunately, you don't need all that for shelling. You just need to look at the plot. But let's do another plot for the shellers. With this one, I'm going to use separate vectors for the high and low tides and plot them in 2 different colors. Close, by the way, closes the figure. And let's decorate our plot with a title and a label for the y-axis, and we'll add a grid. Well, the figure's hidden by the desktop because it comes to the front. That is, the desktop comes to the front when you click in it. I can bring the figure back on top like this. And there it is. And now we can see the high tides up here in blue and the low tides below them in red. It looks like the 10th and 11th of August was some primo shelling. 0, by the way, is the average low tide for the region. It's averaged over 19 years by the National Oceanic and Atmospheric Administration, which provides the historic and predicted tide data from which I got these plots. Well, that's it for plotting. And we have at long last reached the end of our segment on date time and duration objects. That's also the end of Lesson 7. It's a good thing because I am worn out. Don't worry, I'll be back again in Lesson 8, all rested, ready to go, and 3 years younger. See you then.